Thank you. Introduction. So my remarks today largely be drawing from the Stack book that you mentioned coming out this October, and particularly from the Earth layer of the Stack, which I'll talk a bit about. I suppose the framing context in a way I would like to think in some ways my remarks are a bit more optimistic, perhaps echoing sentiment that Rob Holmes mentioned in his talk about the hope that it's possible. He's a landscape architect, that the design from a say molecular to continental scale is still possible, is still desirable, and that to a certain extent that our calculative reason, in my talk, particularly from in relation to algorithmic governance, is still something worth considering. There is a dynamic between natural computation, expressing itself through artificial computing machines, and those machines in turn remaking the world, each bending and counter-simulating itself awkwardly and incompletely in the other. The Earth layer of the accidental megastructure of planetary scale computation, what I call the Stack, is shaped by this irregular and perhaps unsustainable interplay between the one and the other, sensing, drawing, enumerating, consuming, affecting. So while it's a mistake to imagine computation as something that just sprang into existence with the rise of computing machines, or as the superimposition of some synthetic layer on top of everything organic and analog, and ultimately separate from natural algorithmic processes, it's also wrong to imagine computation as existing on some dry virtual plane, sealed off from wet economies of energy, water, arbitrary valuation, remote capture, and geographic chance. So irrespective of the mathematical limits of algorithmic reason, our interest in the Stack begins instead then in the limited and only sufficient compositional capacities of a megastructure already under construction, the thresholds of which are geologic, sociological, economic, chemical, and geopolitical as much as they are calculative. For this, the Earth is understood as a layer in a synthetic machine. And for this, the Earth is the Earth, a physical planet, not a metaphor for nature. There is no planetary scale computation, now a vast network of many billions of little Turing machines that does not intake and absorb the Earth's chemistry in order to function. The Stack is a hungry machine, and while its curated population of algorithms may be all but massless, their processing of earthly material are physical events, and therefore the range of possible translations between informational and mechanical appetites has another limit that is not mathematical, but defined by the real finitude of substances which can force communication between both sides of this encounter. This is made clear by unpacking and sifting through the hardware on which the Stack depends. Silicon is far from the only important substance required in its manufacturing and maintenance, and the economics of its assembly are far from crystalline. The Stack's need for more exotic elements is intense, and even relatively mundane consumer electronics and cloud tethers, aka phones, contain dozens of different minerals and metals sourced from every continent. Some crucial metals drawn largely from the rich and vulnerable mines in Central Africa. In the east of the Democratic Republic of Congo, for example, big chunks and little pebbles of tantalum or coltan, cassiterite, tin, wolframite, tungsten, and gold are pulled by hand from cold, sludgy mountain rivers, often by children, and eventually make their way into the device component supply chain. In 2009, a few mines there produced 13% of the world's coltan, an inert metal used in ubiquitous tiny capacitors, especially in cell phones. From this land, the Belgians took ivory, the Americans cobalt, and now billions of earthlings everywhere carry little bits of Africa around with them in their pockets. The financial rewards of mining and trading in electronics has contributed to devastating effects in the region, including overlapping civil wars in the DRC and next door in Rwanda. And from 1998 to 2003, upwards of 5 million people died in the Congolese Civil War, making it, by one measure, the deadliest conflict since World War II. The extraction and export of minerals, both legal and illegal, has been controlled and taxed by competing militias and mafia. And away from the relative stability of cities, these groups continue to terrorize local populations and use the proceeds of this export trade to finance ongoing wars over local territorial position. The smoldering conflict is a war partially financed with the manufacturing capital of smartphones and laptops. Inevitably, the smooth skin of the device demands gore to feed its gloss. Deforestation in the pursuit of new sources of coltan in remote areas populated by gorillas has also led to an increase in the trade and consumption of bushmeat, a quasi-cannibal economy that parallels the symbolic cannibalism of the widespread war crimes in nearby villages. Exported minerals are sent to smelting companies, mostly in China and India, Thailand and Malaysia, where they are mixed with metals sourced from the world over, Australia and Brazil. Oops, sorry. I lost it. Here. Seems to have gone crazy. No, it won't stop. It won't go forward. Should we? Yeah, why don't you pull that out? I'm sorry, we have to. It won't go. This one. To do it this way. Strange.
Now you have the animations.
Yeah. Okay. Sorry. Apparently the computer is revolting once realizing I was outing their intentions. So more recently, conflict minerals has taken its place among other Coneyisms, and potentially effective legislation has passed, including in the USA, that requires electronics manufacturers to better police their own supply chains. The most heinous circumstances are the most allegorically rich, but even absent the anarchic brutality of these wars and the Conradian odor of campaigns against them, the lesson is more global. There is no stack without a vast immolation and involution of the Earth's mineral cavities. The stack terraforms its host planet by drinking and vomiting its elemental juices and spitting up mobile phones. After its short career as a little computing brick within a larger mega machine, its fate at the dying end of the electronics component life cycle is just as sad. What is called electronic waste inverts the process that pulls entropic reserves of metal and oil from the ground and given form, and instead partially disassembles them and reburies them, sometimes a continent away, sometimes right next door. Minerals originally sourced from the Congo might make their way to California via China before being pulled by hand from a dead phone and burned and buried in Ogbogbloshy, Ghana, or Lagos, Nigeria, two of the most active repositories, just a short way from their original source. So the talk then is on both the ways in which this accidental megastructure of the stack is composed and comprised of the Earth itself, but also the ways in which the Earth, its ecologies, are one of the primary objects of its governing knowledge. The stack then becomes a means by which the chemical ecologies of matter assemble themselves in order to govern other chemical ecologies of matter. Geography, geology, and geodesy converge into interlocking information infrastructures assigned to sensing biochemical reserves, abstracting their measure and status, and in turn providing a recursive medium for their governance. As we'll see, the weight and appetite of this simulation also distorts and in turn eats what it models. Such geographies both complicate and clarify the design of a platform's sovereignty, as much for what they make possible as for what they disrupt. So Google's motto, to organize the world's information and to make it useful, changes meaning when the world itself is seen as being information, such that to organize all the information is to organize all the world. Furthermore, synthetic computation expands what is sensed, measured, calculated, communicated, stored, and worked upon in the first place. That is, the ascendance of digital computing from a narrowly deployed elite scientific military instrument into a general purpose planetary-scale consumer infrastructure transforms what states and other systems of governance can see, can know, and affect. It transforms them into an organ of its organizational cognition. And as sensing extends to all specific surfaces, no longer dumb, but rather now affective, the net sum of what is opened up for spaces or closed off by computation largely defines what it is that any governance platform now chooses to sense or to not sense in general. The information that is sensed and sensible is more often than not on the surfaces of the territory, intensifying governmental focus on them. Skin is the largest sensory organ of any animal body, composed of multiple dermal and epidermal layers, holding organs together and mediating multiple layers of individual interiority and exteriority. The extrapolation of planetary surfaces as epidermis has been intricately linked with the conceptualization of climatic measurement and prediction. Global climate and weather systems have long been a driving application for planetary instrumentation and the understanding of the globe as a vast machine. The interdependence between the image of infrastructure and the infrastructure of the interfacial image is exemplified as the systems logic of a geographic, bioinformational, planetary scale, epidermal sensing and computation megastructure by who else? The Planetary Skin Institute. For this project, the living and breathing geoepidermis is surveyed through a proposed meta-instrumentation of the biosphere into a totally available, archived present, open to interested intervention, collaborative management, and quantified governance. Originally launched cooperatively in 2009 by NASA and Cisco Systems, and now an independent nonprofit research and development platform, Planetary Skin sought to integrate data from many sources into a single branded geo-administrative mechanism. An internal Cisco white paper describes Planetary Skin as, quote, an open network platform for real-time, highly distributed mass remote sensing, authentication, risk profiling, certification, and monitoring of carbon stocks and flows that generates trust and enables collaboration between actors in all three sectors, industry, government, and academia, unquote. Its ultimate ambition is then to provide an open and comprehensive multi-constituent platform for monitoring and governing planetary biological ecological systems, with particular emphasis on water distribution and carbon quantification, ultimately to support pricing of these reserve currencies, we imagine. One early pilot project, Rainforest Skin, would measure the total quantity of carbon contained within the planet's rainforests, perhaps the most immediately leverageable carbon governance opportunity and where CO2 sinks are concentrated by threatened land use. The project would combine data sets drawn from, quote, geo-referenced satellites, unmanned aerial vehicles, and multiple ground-based sensor networks to estimate the forest carbon stock and flow dynamics so as to allow for trading and risk management of this new commodity, unquote. Stack-scale initiatives such as Planetary-Scale, and there are many others, such as HP's Trillion Sensor World Sense, the global central nervous system. These frame the totality of Earth at once so as to identify and track strategic chemical subroutines, such as carbon flows, and to present these totalities back to the whole. This sort of speculative mega-computation is but one way that geoscopy, geography, and geopolitics blur and blend into amalgamated images and territories and governmental techniques, and but one way in which the stack composes its Earth layer. The Planetary-Scale's tagline, "You can't monitor what you can't measure," is a good motto for the big data society, should it ever be clarified at some point in the process who and isn't you. As Planetary-Scale describes its plans, you are likely drawn from the usual stakeholders of technocrats, academics, NGOs, and consultants. The likely effect of this initiative, however, were it or something like it ever fully realized, would not merely extend or consolidate the arrangement of zero-sum governance as we currently know it, but would inevitably introduce other compound subjects and objects, some human and some not, and elevate them from object to subject in uncertain ways. A benefit of these initiatives would not only be the quantification of a status quo, but ultimately to break ground for alternative norms, and to constitute, or at least support, another medium of governance over the biosystems that we can measure and monitor. Planetary-Scale, or some similar descendant platform, might connect with existing governmental and non-governmental biopolitical authorities, supporting, augmenting, superseding them, and through ecumenic platform interoperability, would ultimately become itself a governing authority. Through neutral simulation and visualization of ground-level patterns upon which any large-scale carbon trading markets would depend, a platform like this could clarify the carbon stocks that might be traded or sequestered, as well as validate treaty verifications or violations. This would help turn matter into money by providing a kind of financial transparency, in this case, of financialized molecules. Such many platform projects are emblematic of the stack's incorporation of the Earth as a layer, and would convene political authority not by starting from scratch, but by remeasuring and reframing and re-instrumentalizing some already existing geographic whole. They generate comprehensive quantifications of processes and patterns which, to the extent that they operate as intended, can also take on effective force of law within an expanded eco-political jurisdiction, even if their claims are not ratified by states, Westphalian or post-Westphalian, to do so. Further, as these meta-technologies of ecological observation become necessary to even perceive the contours of ecological risk, they enter directly into the programmatic center of governance as such. This is not internationalism, however. The force of platforms is different, for example, from the eco-globalism feared by conspiratorial isolationists, all spittle-lipped over Agenda 21, in that there is, according to design, at least no central commanding body outside of the architecture of the platform itself. Such platforms, in principle, may even work for better or worse to undermine forms of political centralization that they themselves do not or cannot calculate or articulate. That said, nothing is certain. A transference of sovereignty from the declared self-interest of whoever counts as a citizen into the calculation of carbon and energy binds one inhale and another exhale across continents, and so guarantees, at the very least, indecipherable accounting paradoxes. Computation, in essence, is training governance to see the world as it does and to be blind like it is. If over time something sees for the state, on behalf of the state and in place of the state, it does so by seeing as a state. or by seeing as something like the state, or something like the state has yet to become, but would become once it is trained by these same new tools of perception and blindness. As the state involves new techniques into itself, those techniques also absorb, displace, and diminish the state by controlling access to unique jurisdictions that the state cannot otherwise possibly comprehend without their help. While it extends jurisdictionality, it matters quite a lot if the stack also confiscates and multiplies that jurisdictionality. It doesn't merely accelerate or open up governance as presently configured, it invents substitutions as alternative jurisdictions appear, linking cellular biology to macroecologies to computational geopolitics, some enduring for seconds, others perhaps for centuries. Macroscopic platforms such as these frame the Earth as a competitive archive sorted into a quantifiable past, an atemporal superficial now, and a predictive virtualization of its futures from which models and simulations, its preferred instruments of governance, can be derived. And through this, opacity and privacy are redefined by a spectacle of transparency, as the platform's authority is based on the quantity and quality of its data and from the means to translate that stash into instrumental simulations of error-corrected pasts, presents, and futures. From Cisco, NASA, Google, etc., these data are available for free or on a subscription basis as provided with an invitation to innovate vertical markets with their data sets and tools. Geo-epidermal megastructures such as these realize their political value through the immediate and potential events that they can sense, and their economic value through the currencies that they can verify for the users. And so they are themselves dependent on enabling users to actively engage platform interfaces and to act back upon the materials that they represent. Platforms are machines as well as maps, an engine, not a camera, as Mackenzie says, and tools to compose things, not just to measure them. And so the slogan, you can't monitor what you can't measure, may need to be revised to include the Foucauldian line, you can't modify what you can't monitor. Or even, you can't not modify whatever it is that you sense. I wanted to then just a quick discussion on the weight of the model itself. One of the chief ironies, paradoxes, if you like, of these sorts of planetary scale instrumental systems is that on the one hand, they have an enormous energy, carbon, and mineral appetite. And on the other hand, they themselves, as sensing mechanisms, are the means by which we can understand that climate change is happening, can measure it, can give a kind of can quantify the Anthropocene. They are both the measurement and the event itself. I think I've told this story, but some years ago I was on a panel with HP research scientist who had recounted an assignment that he had once been given. He was part of a group of computer scientists who had been asked by then Vice President Gore to propose an architecture for a computer that would be capable of monitoring and simulating the entire planetary climate in real time. And this group concluded that such a machine would require zeta-flop computing, which is a system capable of over 1,000 floating point operations per second. At the time, the fastest computer measured were petaflops, exaflops still years away. So he discussed how that it may have been possible to do this with very different processing architectures based on nanoswitches and so forth and so on. He talked of layers of nanoscale, weaving this into different sorts of flows. And then rather anticlimactically, he shared the conclusion of the group's report was that based on foreseeable technology, the specs of the computer requested, it would be roughly the size of Paris, and that it would consume so much energy that it would be the single most significant event that it itself would be monitoring. And short of fundamental breakthroughs, his anecdote underscores the paradoxical recursivity that undergirds the demand for global ecological omniscience. We expect complementary and contradictory effects, and this may re-situate computational technology closer to its elemental origins. It may suggest alternative geoengineering projects as the critical design program. It may introduce a less virtual chemistry of reserve currencies, may inaugurate a new sovereignty of sensation. It may sponsor the construction of a global metrical megastructure that is forever weighing its own girth and imposition, a smart grid eating its own tail. I want to conclude then with just a few remarks on the Anthropocene and the formulation of the human subject as a geologic actor, and on the geopolitics of what we may call the post-Anthropocene, the formulation of a time to come, one in which some other species is that dominant geologic actor. And to do so is harder than it should be. To pick two, and there are many, Heideggerians and singularitarians, two groups with much more in common, and two with which than they would think, and two with which I have my own ongoing battles, have made it unnecessarily difficult to think and talk about species and technology. They have made the inevitable, whether we want to do it or not, geoengineering project that really actually constitutes the eco-geopolitics of the 21st century into something that is either disqualified a priori as a metaphysical atrocity, or something that simply happened, that will simply sort itself out by the invisible hand of Moore's law. In their fetishization of the human experience for one, and the psychotic promotion of the self as a stable physical entity that can be expanded exponentially without exploding into fractal plurality for the other. Both make it far too difficult to see that geoengineering, or better just geodesign project, for what it should be, more like molecular gastronomy at landscape scale. A resorted and or restored ecology designed to taste itself in new forms, a richly spiced and sauced mutual ingestion. A side effect of NASA's unmanned programs, particularly Viking's initial probes to the surface of Mars, is what Kim Stanley Robinson calls comparative planetology, the consideration of pattern and difference among astronomical bodies. Arguably, the leverage of such a perspective is greater than that of the more iconic visual knowledge of the Apollonian Apollo Earthrise or blue marble photographs, which demonstrated the formal coherency of Earth as a geophysical unit. Now the special singularity of that unit can be measured by variation among like and unlike cousins, each of which represents an alternative chemical reality from which or toward which our own perch might be distinguished and interpreted. And given that other planets are assembled from the same chemical ingredients of the Earth, still mostly hydrogen, helium, some carbon, bits of other things, albeit in different ratios, the far end of comparability is the possible search space of elements computing one another into relative molecular stability of a planetary sphere. The universe could, in principle, disassemble one astronomic body and build a couple others out of the raw material. And in point of fact, in astronomic time, that is more or less how planets are made. So seen from this outside, the Earth layer of the stack is ultimately not only the plateau from which the energies, the mineral and material that run the other layer are drawn in a kind of closed tower. It is also, in essence, the basis of something like a secondary planetary computer, one laid on top of the first systems whose calculations resulted in the relative ecological and chemical stability of our own first planetary situation. Often pervasive computing is described as a diagnosis model, providing us with a way to detect pathologies. We detect pollution in one way or another and then render it. It is a way to visualize the invisible evil, drawing a picture so that we can see where it goes, where it is, and in one way or another prevent it from ever happening again. The maximal design image of pervasive computation of this second planetary computer is more than that, more than a smearing of the planet's surface with an objective computational film that would construct a stream of information about the performance of our shared socio-natural spaces through which geopolitical decisions can be made. Within a material public based on a truly ubiquitous computational infrastructure, the political formations that would emerge might be based on the aggregation of encounters and relationships between persons, things, and material events, including and especially those in which people are not directly involved. But even if everything is seen and registered, not everything sees or works back upon what it sees in the same way. Part of the design question then has to do with the status of the image of the world that is created by this secondary planetary computer, as well as its image of itself, and the way that it governs the planet by governing its model of that planet. That model of the material public is built largely on the interrelationship of non-human ecological actors. And so the images that the designer can deduce and produce serve to give representational agency to a material matrix that otherwise would be invisible to itself beyond the most local chemical interactions. The status then of the non-human in relation to the designer, considered in terms of emergent models of software and sovereignty, conjoins sensing, sense-making, and image-making into a generic infrastructure of sensors, databases, displays, firmware in the wild. In other words, a stack system that both reflects and congeals what it represents, both technically and politically. The columns going up and down the paths of the stack link a politics that are capable of seeing into a politics capable of seeing us, and through it one becomes the other. It compiles a diagnostic image diagramming present and potential relationships between agents within its line of sight. We assume that any human or non-human component's ability to recognize and consume that image, and thereby also consume the projection of a set of potential governable relationships between the variables within that image, does so not just for utilitarian imperatives, but with real affective intensity. In this utility and intensity, another proposition is made about how it is that we may sense the world, or how the sensibility of the world might be distributed or organized, made infrastructural, and activated to become a part of a landscape that understands and narrates itself. It is not only an image, it is a tool for a politics that doesn't yet exist. Emerging from the parametric multiplication and algorithmic conjugation of our surplus of projective images, interfaces to come, perhaps in mimetic accordance with one explicit utopian conception or another, and perhaps not. Nonetheless, what is and is not governable, and how it is and is not to be governed, may arise as much from what the model computational image cannot do as from what it can. Its geopolitical effects are as reliant upon stockpiles of failures as upon capacities for success. This is no less true of the surplus of interfacial utopias that constitute the affect of information visualization than it is for the parliamentary politics born of an agrarian time, but persisting long enough to provide funding for those Viking missions to Mars. So what can we say comes after the Anthropocene? Michael Whelan this morning, he said that there was no escape. Werner Vinge, who spoke with last week, argued that he thought it would be the shortest geologic era ever. The only thing that we can know about the post-Anthropocene is that it is an era in which humans are no longer the dominant geologic actor. Some new earthling species may prove to be more fit, better at making the next evolutionary steps than humans are. And so for us to, quote, survive, we may have to become more like them and less like what we are now. In the longer view, humans' role may be that of an enabling intermediary between early primates and as yet to emerge phyla that blend organic and inorganic flesh and thinking. This is the point of convergence between robust artificial intelligence and the deep ecologies of voluntary human extinction. Instead of disappearing, however, we survive by perforating the boundaries between animal, vegetable, and mineral. In this light, we see that pleas to make technology serve humans and to serve human needs, desires, and requirements are misguided and even suicidal. Staring upon the abyss of mass extinction, a drearily common refrain, variously explicit or latent, is to identify modern technology as the main culprit, and to conclude that the most fundamental solution is to de-technologize the planet and to rehumanize ourselves, once presupposing the other in measure. This is among the worst possible plans, both philosophically and practically. First, it is tragically deaf to the priceless Copernican trauma of the anthropogenic precipice, that our status as the dominant geologic actor is fleeting, and that in order to survive, we will have to become something that is not necessarily and recognizably human. Second, it props up a psychotic misrecognition of what humans, humanity, and humanism actually are. We are the brain-eating apes with weaponized hydrogen atoms who organize our societies according to Bronze Age poetry on human sacrifice and ritual purification. Among the last projects to support is rehumanization in any sense of a direct return to historical norms. I think the other species, animal, vegetable, and especially mineral, would agree. Thank you.